So I coded and trained fully from scratch this coding large language model in this video. I will show you how it works and then I will show you how I did it. Here I wanted to make it solve a specific task, although we could use same language model architecture for any general coding task. But here I just had data that converts a Python function like a plus b into highly optimized Triton kernels that run very fast on GPU. So you see, this is what language model generated from this prompt. Yeah, this prompt. It does know the structure of Triton. Now, I only trained it with on 20 examples, while we need 20,000 examples. So in this, I did not have enough data for this video. I just generated 20 examples. So that's why it's using sign instead of maybe plus or something. There are some mistakes here. It's not actually working 100%. But you see that it knows how to generate the syntax of Triton. And if I spent maybe $1 to $10 and I had a lot more, 100 times, 1,000 times more data, then this problem is very, very solvable. I can also try maybe absolute value of a, although this is not correct Python function. Let's see. And it correctly wrote absolute of x, it understands. Even though this is not even correct, we don't even have this on data, so this is actually better than I expected. And here it seems like it's also writing Python function of absolute value. This is actually better than I expected. Although this shouldn't be here, this is issue with our training data, I'm pretty sure, but this part is really good. It's better than I expected because this is not even this is not appearing in data either. And it learned to understand what it is. The goal is for LLM to see a Python function and from that to create this very optimized Triton function that runs faster. It's the same function, just faster in Triton. So here we have a Python function, a plus b, and then same function implemented in Triton. So if I'm training LLM, first I just need this part, I'm thinking. I don't need it to even learn this return, even though it's simple, or to learn this, it's all irrelevant. I just need this part, the actual Python code, and I probably don't need this part at all because from this part, some other LLM can figure out which arguments to maybe put in, or we can train even smaller model for just the arguments, but that's not important. I would just give it this and tell it to convert it to this. And that's how we train our LLM. And then we can structure around these things with other LLMs or just programmatically or something. Although it seems like when generating data, we need to generate whole file so we can run it and test if actually this gives same result. This gives same result as this. And then we need to somehow just extract this maybe with some Python script or something. If we look at a bit more complex one, I think we still don't need this return because it will learn that in the end we don't have this equal sign in the last line, so it will never generate it and we will just insert return in the last line and that's it programmatically later without LLM needing to learn that. So looking into this, LLM would need to learn what, for example, this mean means. I guess it would learn that torch.mean comes together. And when it sees this, then it needs to do something here, translate it somehow. But this is very structured code. It's repetitive in a bunch of examples. It's always like this part is always same. All of these things are very similar example to example. It would just need to learn what sigmoid is and these things. And for every new possible PyTorch function like sigmoid, we need to teach it what it is. So we need to have some data for every new function somehow. I think we can generate it somehow. Because even if you never saw sigmoid, you would not know how to code it if you don't know what it is. So the first part of training would be just using already existing LLMs to generate these codes and different functions. We need to only select for ones that compile, that work, that are same. So if this has mistake, doesn't work, so we don't want to use that in training. We need to include all of these Triton functions in the training so it learns what each one does. So I think there are two things we need to focus on. One is to cover all of the functions with training data, maybe even a few examples. I hope that would be enough. And then other part is generalization onto complex tasks. So we need to somehow create a bit more complex examples where it learns to combine these functions, and we need to teach it explicitly how to generalize and combine these functions, even if it never saw these combinations in the training. And I think we can do that by just generating some combinations data, a bunch of data that combines different functions, and it will eventually learn how to combine them. So I generated a bunch of these Python Triton pairs, and actually 50% of them are correct, which is actually quite high. I didn't expect it. I used Gemini and Qwen to generate them. I don't know which one was better. Next, I'm gonna copy this. I need to check if it actually works, because it did generate the tests. So it looks like this is correct. These two functions match. So then I would just extract this part without return and give it this part, the LLM, and then tell it to predict this part. And I don't know about comments. I think we don't even need comments, because comments are just additional general language complexity. We don't need that. I just want to have these numbers here and these commands that are always same. To learn to comment, it needs to literally learn English, entire English, which I don't want it to do even. It looks like entire Triton language has just this many commands. There is like how many? Not even 50 commands. So if we just learn this, we know entire Triton language. And then we just give it a bunch of tasks. One of the ways data generation fails is that language model like Gemini or Qwen doesn't know which of these commands Triton has, which it doesn't have. So it tries to use tonnage, but Triton doesn't have tonnage. So I'll just give it all of these functions and tell it to use one of these. These are only ones that Triton has. And I'm using this model accidentally instead of Coder. Is it possible that it's better at coding, because I didn't have any mistakes until now? I'll try both. One trick is you can just copy all of this like that and just paste it like this into Qwen code, because even though it's not formatted like in JSON or anything, it's gonna understand. It's gonna understand that this is and this, and it's smart enough to understand what is what. So don't get into a trap of wasting time doing all of these details that are not necessary, like refining that. And then these are all functions Triton has. It has nothing else, so choose one of these randomly. Don't choose one too often. Next one, but print full results. I can maybe separate a bit. Print all numbers that are outputted from both functions. Okay. So I guess this is kind of stuff we would eventually combine into a single kernel, but we need to get to this point with synthetic data and slowly creating a curriculum learning and using our trained model to generate more of these functions, so we can run it 50 times and just pick one that outputs correctly and then save that as training data, so it's gonna self-recursively generate training data and train. Qwen Coder is able to generate this data correctly, although right now a bit simpler. I'll try a bit more difficult data, but even if it cannot, then we'll just train on this simpler data. It will learn to generalize and then use that trained model to generate its own data and generate a bunch and then pick ones that work. It looks like it selects these functions first, which is cool, and then writes Python function and then writes the Triton function, although okay, I don't know if this is, I think it's not cheating, because in the training it will just see this Python function and it needs to learn how to do all of this. Let's do a bit more complex tensor operations and parallelizations. Let's see how it handles that. It looks like it's able to do this as well. Okay, this model is actually pretty good. Now we are able to just train our model with this because it works. We probably also want to remove print statements because this is plain language. We don't want it to learn English. We just want it to learn commands and what each means and how to convert from one to the other. You see, just the Qwen text model actually starts to fail. I wonder if it's using more difficult tasks though. Maybe it is. Look how difficult this is. But I think let's just use Coder. So for example, a bit more complex one like this, neither Coder is able to do this. In some sense, we are starting from distilling Qwen 3 coder, which is a huge model, into our small model, and then we will make our small model even better, faster. I want to actually start with Gemini. I feel like Gemini is better, but I'm gonna use both of them maybe. This is good. I think these CLIs, especially fridge CLIs like Gemini and Qwen, are good to generate this data. So it generated 2 files. I told it, okay, I need this to be in 1 file and create this function to test them and put it into data folder. I think they are good. Now we want to just go step by step. Now I'm going to tell it to remove comments. So I'm going to just re-implement what I tested in my chatbot UI on Qwen. I'm just going to re-implement it here in this pipeline. I'm wondering if you can always infer this function from this Python function without needing this wrapper. I think we can. So I think we can just make it learn this from this. It's very nice that it's creating all of these complex data points. I need to ask it how do I later check programmatically and quickly if all of these generated files actually have same function. So right now I'm manually checking, but how do I do it programmatically? Looks like we have it, and looks like both of our tests passed. So Gemini wrote the file. Now I wanted to create another file for all of the functions that pass. This is the prompt. So I wanted to extract the body of the Python function without return in one column, and body of the Triton function in the other column without arguments and without names. It looks like I got it to work. I just told it to add these notations around bodies and then to use that to extract it, and now it works. Before that, neither Opus could solve it. I'm running it on Google Colab, so I just push on GitHub pull here and run on this CUDA because I'm using MacBook, so I don't have like CUDA. It just requires a lot of manual trying and setup and testing because there are some little bugs that you need to fix manually always. And then once we figure out the pipeline, we will just let it run. Finally, it looks like my data generation pipeline works. And now it's able to extract Python function and the Triton kernel. Now I told it to train on this LLM Pi on this training data. I just told it to take Python body and predict the Triton body as next tokens. I finished data generation, and it looks like the model is training now, but I'm gonna see if it's training properly. I just generated about 20-30 files. Ignore this number 1000, that's not the number of files. And the amount of data is actually not that big. This is all of the data from here to there. This is definitely not entire internet of data as these people train. This is not enough data. I need to generate like orders of magnitude more data. But this is just a proof of concept. Am I gonna continue doing this? Maybe, or somebody else, some PhD students, MIT, Shanghai AI Lab, or whoever might continue doing this research. I'm pretty sure generating highly optimized code for GPUs from Python code is very solvable and doesn't need like general knowledge at all. It's very solvable. I'm surprised that it's not solved by now. I don't think there is like some very difficult reason to do it, so that's the reason. I think it's just nobody solved it yet. And it's training here Epoch 3. I don't know what it's gonna generate. I didn't look at the code 100%, but we'll see the inference. So it should generate from Python the Triton function from Python. So if I give it Python function in the inference, it should just generate the Triton version. And I'm training on Google Colab, the free GPU, going 10 times over data. It's gonna memorize data. It is what it is. We have too little data. The main thing in this video we discovered is process of generating synthetic data, coding data especially, where you can verify by running it. Let's just see what our language model will learn now. I trained it, so it says enter Python function. Let's see a plus b. Generating Triton kernel for a plus b. Let's see what we got here. Well, first of all, we do have correct Triton code. Secondly, there are some mistakes of indentation. This was wrong with our training data. If I check my training data, we also have these indentations. So that's the problem in the training data. But we do have, seems to be correct Triton code. I don't know why it has this return. So I'm not sure what this part is. Maybe a wrong setup problem with our training setup. But here, Python function, you see, this is showing the next Python function for some reason. I don't know why. Maybe problem with training, probably data. But this seems correct. If I say a.unsqueeze, let's see. Okay, seems to have it a bit rough. Result is absolute. Why is it just taking absolute? Am I even doing inference correctly? Okay, just let me try a plus b again. Okay, this seems better. Oh, it's taking absolute again. Okay, anyways, our training data is not good at all. 20 examples. We need 20,000 examples. But this was just proof of concept. Not even proof of concept, but just a research idea and how I will go about it. So that was a proof of concept. We need better data, more data, way more data. It's gonna cost me some money, I think, maybe in API credits, but you can check other videos here. This is how I was also thinking about generating this data. So this is maybe part 1 to this video. And I made these LLMs like medical LLM, image from scratch, this LLM. If you wanna learn from scratch all of this, then I recommend you just search for Qwen 3 from scratch and then watch this tutorial, this one, and then you can learn and follow the guide. Check out other videos on my channel and see you next time.